Hello. I had this idea to do like a, just a journal type of devlog on YouTube for all of my projects. To organize my thoughts and kind of keep track of what I'm working on, because if I don't do that, then I get bored and I forget the whole point of what I'm working on. So maybe if I make these kind of like journal entries, I'll remember. So yeah, this is the engine in its current state. It I added this kind of like wall running thing. It's kind of cool. The problem with it when you jump in the beginning is that you go through the ceiling, and the reason is because I'm not clamping the initial velocity. It just multiplies your upwards velocity by just a scale. So that's why you get these kind of smooth curves. But I definitely need to clamp the bottom so that you don't shoot through the ceiling when you do it right when you jump. So how I got this kind of smooth velocity was it's basically it's averaging. Well, it's not averaging. So what it essentially does is every frame it takes your initial velocity, and then it applies its wall normal kind of velocity vector, and then if the vector increased in size, then it takes a fraction of that and then multiplies your velocity by that fraction. And so you don't get like speed increases, and so speed stays consistent on the walls. And so you have that, and then when you press Q, I was implementing kind of this like, you come off the wall sort of thing. But it doesn't really work. I need to figure out a way to like, I don't want it to like kick off just perpendicular to the wall normal. I kind of want it to just go with the player camera. So I added kind of like, oh, this steer direction is going to be like multiplied times 2 on the frame that you press Q, so that you kind of get this jump off in a different direction, but it doesn't really work properly. So it's just a boolean that says that this frame is going to be the kickoff. So I should probably just add like just a flat value to player speed in the direction that they're facing, instead of just trying to do complicated vector math with it. So they implemented crouching. The crouching does go through the floor when you jump, though, because of the little head bob that I have. So I need to fix that. Player camera does clip through the wall, or only in corners now. I added the collision radius, changed that a bit. But yeah, this is something that I gotta fix. Definitely gotta fix the corner collision on walls going through because that's kind of ugly. So we added this fog. I guess I should talk about where it started. So I kind of wanted to make like my own engine in C, because I had this dream of kind of this like really cool kind of like Argento type of giallo lighted horror game, and I was like, do I really want to use somebody else's engine to build this? No, because I don't know, I had like a very specific type of vision for it, that copying and pasting a shader into Unity isn't going to really give me that feel. So I wanted to make something that was kind of true to PS1 and old hardware, while so we render everything at PS1 resolution, right? And the kind of the great thing about that is that I can do a lot of complicated and expensive calculations that would be really difficult to pull off on a higher resolution, especially because I have a shitty PC, and I think people that have shitty PCs should be able to play cool games. Every indie game now is just, it doesn't look as great as it should be for how badly it runs, and I just wanted a way to make things run good but also look really cool. And I don't think high resolution looks that great to me. I really like the lower resolution upscaled, and that's what I decided to stick with. I mean, technically you can just change the low res initial resolution. You can scale that up to whatever you want, but right now it's just PS1 resolution. That was kind of the idea for the engine. I made it in C because it's the only language that really makes sense for something like this. And I've been working in OpenGL on some other simulation projects, but this is, of course, going to be the biggest one. So I kind of just started with Raycaster, just doing walls and a ceiling, just one by one, right? And that worked, but I learned the limitations of a Raycaster. I was like, I'm really going to push the limitations of what I can do with this math, right? Like, now on new hardware, I can definitely push the limitations of what Doom was able to do, and I got into that math, and then I realized, okay, this isn't worth it at all, and it's going to run really poorly. So I just decided to basically refactor everything from the start. So now nothing is raycasted, not even light is raycasted. The only thing that is actually raymarched is this fog. This fog is raymarched on the GPU in real time, which is pretty cool. It is an expensive calculation, and it isn't necessary to get this fog effect. I can do it without it, but it won't look as dynamic and cool. It does need to be tuned because it gets really, really bright when you're inside of it, but I think from outside it looks kind of cool. You might not be able to see this kind of like ring around it. It's pretty soft right now, but you can turn it up and tweak it. I've been playing around with it. You can also see it in the distance. That little white kind of, that's all actually accumulated all the way into the distance. It's all accumulated into the distance. It just like shoots, ray marches out and accumulates every piece of light map, right? So that's how that works. Right now, we can make slopes. We can do any type of geometry that's technically just supported by my renderer. The problem is really making maps. Right now, everything is just voxel based. So everything is just a kind of flattened array of map tiles, right? Where each tile just says, oh, the ceiling is this high here, and the floor is at this position here. So you technically we have all the vertexes and everything set up to do more complicated geometry. I just haven't. I need to make like a map editor. Is the problem, which is my next thing that I'm working on today. Is I'm going to start working on that, and that's going to take a while. Is to make this sort of map editing client that's able to calculate all the slope normals when you place them and stuff like that, and then implementing that, and then I have to refactor a bunch of, well, not a bunch, I made it so that it's not going to be as painful as it would have been otherwise. But anyway, I'm rambling a bit. So light started as raycasted on the CPU, and I thought that it was a super cool effect. But I also did this cool, and actually switched to my code here. I'm kind of worried about showing my code because it is kind of like a war zone. Oh, it is kind of laggy too. But yeah, so I had this code here, which was my initial 2D kind of raycasted light without z-axis, essentially. And this code is kind of jank, but the cool thing that it does is it tracks depth changes. It tracks depth changes so that it finds edges at the side of walls. So the cool thing about this raycast light that was kind of my own implementation was that once it finds an edge, it refines the edge by shooting out thinner rays to get kind of like exactly where the corner is of whatever it's trying to cast a shadow around, and then it kind of peeks around and shoots light around it. So the effect of that, if I can go back to here, would be kind of like that this becomes like a little bit more realistic, right? With the raycasted light, this angle just wasn't only a creep around, it was a kind of like a stark type of line coming out at an angle there, and I really like that effect. So that was something that was kind of sad to let go, but this method of lighting right now is a lot better. And right now it just looks radial because that's all I've implemented, but in the future, all of this is pre-computed light map stuff. So none of this is actually done in real time other than the fog, of course. We on Mapload, we basically pre-compute a 3D voxel light map of every single tile, and then we just sample it every frame. And so the fact that we pre-compute that all at load time, I can do some pretty complicated calculations and make this not just a circle in the future if I so choose. You know, I have to really delve into the math of kind of getting this more streaky and stuff, but I have all the data to do that. It's just a matter of doing the math, right? So I have to figure that out. What else? So that's that. Our new algorithm is a DDA algorithm for the light. I don't know why I'm saying we, it's just me. So essentially what it does is it just kind of just iterates over the whole thing and then just samples what it should put at that voxel from a lookup table, and then it accumulates all of it. The occlusion took a long time to figure out. It's really actually touchy because you can kind of see it through the wall actually if I go through. So this is right on that border. So what ends up happening is, because we are at low resolution and everything is done at low resolution, it gives us all these cool kind of glitchy sort of effects and wonky sort of effects. But the problem is, when you want to do really delicate stuff like lighting, just a little bit of a rounding error can cause really disgusting problems. Like, for example, like going through walls where it shouldn't, because we create we recreate the world position based on fragments and stuff in the shaders, and if that gets rounded, then you get light going through walls, which is really bad. So what I discovered was that basically the math for the voxels of the light map is literally too precise. So if you think about it, one voxel is on this side of the wall, one voxel is on the other side of the wall. The wall doesn't know which one to choose, right? So you get these awful aliasing effects if you don't bias it in a certain direction. And so now we store every single wall normal and bias it by hand. Every wall gets biased per frame based on, you know, what direction you're looking at it and what direction it's facing, so that you don't get light going through walls, and you don't get basically it's sampling two parts of the light map at each different pixel. like was happening before was you had this awful aliasing artifact when you looked at certain surfaces where it would just like glitch and move around as you move around your camera because it's sampling 2 voxels at the same time based on fragment in the shader. And that took way too long to figure out. That took like a day to bug fix that because I was sure it was something with the DDA algorithm, but it wasn't. It was just the GPU side. But yeah, the occlusion took a while. The fog occlusion took a while because how I was recreating my position from the inverse camera matrices and linearizing depth, and that's a whole rabbit hole that I don't want to get into. What else? What else did I want to talk about? Oh yeah, the movement. So the movement is source, essentially. I literally just like looked at the source engine source code, and I was like, okay, you know, let's just copy what this does. It doesn't copy it exactly, you know. I kind of wanted to have this Quake style this sort of strafing as well. It works really good. There's no bugs with the movement, really. It's just not as kind of responsive to really sharp strafes like sources. Like in source you can really do this and then pick up speed. Here you can't. Here you have to kind of do this, right? I don't really know how to fix that. I've toured around with the values a lot and moving a bunch of equations around and squaring this and, you know, normalizing this and, you know, doing math with lengths of vectors so that speed is affected more by other things, but this is how it's going to be for right now. I think it's a good point with it, and yeah. So I guess I could. Once again, I don't really like showing my code, but I guess I could. Right now, the problem is that everything, because I have ADHD, everything is fucking everywhere. Yes. Yeah, so this is basically what it is. You see this disgusting kickoff code here, but so right now, this is kind of separated just to show you what it does. Essentially this calculates alignment with the wish direction from your current direction, and then applies a nudge based on how aligned you are. Except it's really touchy. So if I change these values, things will get really touchy. So this is 2 right now, which is a value that I felt was good. But anyway, yeah, it's complicated. It doesn't get... So I didn't like capping it. So I had this idea to like basically take your length of your vector before and the length after the nudge, and then just cap the nudge based on the length of your first velocity. But that just doesn't feel good. You need a little bit of speed, but not too much speed. But you also want control, but the control requires the speed. So yeah, it's all very touchy. How long is this video now? Wow, that's 20 minutes of me talking. Wow, that's way too much talking. All of these textures and stuff I didn't make. I don't know if I'm a jackass for not citing my sources for these things. I really need to keep like a paper trail. These are all, I believe, Creative Commons. It's a really good torch. So yeah, the sprites are just billboarded and they face the direction. Also, this alpha channel is probably a one-line fix in my code. I just have to look up how to do it so that it doesn't interfere with the lighting. I think it's just changing the blend mode. I'm just stupid and I can't figure it out right now. But yeah, the next step right now is today I'm going to work on a map editing GUI. Start working on that. It's probably going to use Nuclear, which is a C GUI library that's pretty simple to use. I used it for my my Linea implementation that I did, because there just aren't really a lot of great C GUI libraries, are there? It's kind of a pain, but Nuclear works. I tried ImGUI in C, and it's just impossible to link. I was like spending, way too long trying to link that, and I just want something that works, and Nuclear just kind of works. So yeah, that's pretty much everything that I wanted to talk about. This skybox is also kind of scuffed. But I guess I'll do these weekly as long as I keep up with it. Also, all this sine wave modulation has to change. It's way too obvious that it's just waves, so all that has to change too. This is just kind of laying the groundwork for it, but I think it looks cool. I'm pretty proud of it so far, so I hope that I stick with it. I don't really know what the game is anymore. Is the thing is that I had this idea for this it's kind of like RPG sort of dungeon crawler, but now it's kind of turned into like a movement shooter all of a sudden, just because I'm just adding a bunch of things that I like. But I guess that's not a bad thing. I think I like a bunch of cool shit and I should have it in the engine. But I think that ultimately it wasn't really about making a game per se. It was like I kind of wanted to make something my own way. I just don't think that I think that all the tools out there just really oversimplify things until the point that you make something that isn't as good as it could be if you just made it yourself, So the idea is hopefully that by learning all this stuff from scratch, I'm able to make something that's kind of truer to my vision than if I just took the lazy way out. As far as this kind of demo being playable, I guess I'm hoping that eventually I put some sort of demo out, because I think that movement in this, I guess I haven't demoed it because I've been talking so much, but movement in this is actually kind of fun. It actually is kind of proper BI movement. If I don't fuck up, movement in this is kind of fun already. So I definitely see potential in that. But there's definitely a long way to go. The part that I'm dreading is really if I want to model and do sprite work and stuff and all that, I don't really, I kind of suck at doing visual art that isn't coded like this. I just don't have the hands for it, the skill. So I don't really want to learn Blender or whatever. So that's going to be interesting to see. But all that stuff has to get done too if I want to have a proper sort of thing set up. I definitely don't have the money to pay anyone else to do it. So anyway, guess that's the video. I don't know if I'll make them at week increments or whatever, but I don't really know if anybody's gonna watch this either, but I figure maybe I'd look back on this one day and remember all the work that I did, because I tend to have a really bad memory and then forget all the cool shit I've done. Anyway, I guess that's it. Yeah, if you have any questions or you know, any specific questions on how anything works, making something like this is really interesting, because it kind of, now I realize just how much goes into it, and how you know, making something like I'm doing it, you know, rather than starting with, you know, learning for example, like actual like modeling and like how to load in models from Blender or whatever, like starting from just like the math and the geometry side and generating everything is kind of like a backwards way to do it. So it's given me a unique perspective, and there isn't like a ton of like resources out there about like how to structure something like this. So if anybody has like a specific question that I'd be able to answer, I'd definitely be open to doing that. Anyway, so that's it.